All right, let's dive in. Today, we're pulling back the curtain on the secret weapons of software testers, test design techniques. These are the really clever systematic tricks that make sure the apps and websites we use every single day don't just, fall apart. So let's get into it. It all kicks off with this massive, kinda impossible question that testers grapple with constantly. I mean, if you want to be 100% sure an app is bug-free, how on earth can you test every single thing a person might do? The number of potential inputs, clicks, and weird combinations is practically infinite. To make this super clear, let's just picture a simple example. A little input box on a form. All it does is ask for your age, and it's only supposed to accept numbers between 18 and 30. Seems easy enough, right? Well, think again. If you wanted to be absolutely 100% positive it works, you'd have to test every single valid age, then every invalid age below 18, 17, 16, all the way down to 0, negative numbers, then every invalid age above 30. And what about typing in letters or symbols? What if you just leave it blank and hit enter? You see where this is going? The list is literally endless. This whole idea is called exhaustive testing, and it's just plain impossible.
So, that's the mountain we have to climb. An impossible task. You simply cannot test everything. So, what do?
Well, the solution isn't about working harder, it's about working smarter. And that brings us to the core principle here. Instead of trying to do the impossible, testers use a powerful toolkit called test design techniques.
And here's what that really means. Test design techniques are all about being strategic. They're smart methods for picking a small, manageable number of things to test that give you the biggest bang for your buck, the maximum possible confidence that you've covered all the important stuff. And this is where it gets really cool, because you've got these two goals that sound like they completely contradict each other, right? On one hand, you want to reduce the amount of work you do. On the other, you want to increase your confidence in the results. It's not about testing more. It's all about testing smarter. Okay, so let's start with the first set of techniques. These are absolutely perfect for that age box example we talked about. They're all about how to intelligently tackle input fields. Our first technique has a bit of a fancy name, but trust me, the idea behind it is super simple. Equivalence class partitioning. Basically, instead of testing every single number in the universe, you just divide all the possibilities into a few logical groups or classes.
So for our age box, we can create 3 really simple classes. Class 1 is our valid group, any number from 18 to 30. Class 2 is an invalid group, any number less than 18. And Class 3 is our other invalid group, any number greater than 30. And here's the powerful logic. If you test just one value from each class, say 25, 10, and 40, you can be pretty darn confident about how all the other numbers in those groups will behave. Just like that, an infinite list becomes 3 simple tests. How cool is that?
Okay, on to our next technique. This one is born from decades of real-world experience, because we've learned something really important. Bugs, they love to hide out at the edges. Boundary value analysis is all about focusing our testing right where errors are most likely to be hiding, at the boundaries of our ranges.
So using our age box again, we're going to zero in on those boundaries of 18 and 30. We test the minimum value, 18, and then we test the numbers right next to it, 17 on the outside and 19 on the inside. We do the exact same thing for the maximum. We test 30 and then 29 and 31. With just those 6 tests, we've targeted the most critical, most error-prone spots of that entire feature.
Now, testing isn't always about simple input boxes, right? A lot of modern software is built on complex business rules and all sorts of logic. So for that, we need a different set of tools. First up are decision tables. This is honestly a brilliant way to systematically map out all the different combinations of conditions to make sure you've tested every possible outcome of a complicated rule. Just imagine you're transferring money in a banking app. There are multiple conditions, right? Is the account approved? Does the one-time password match? Is there enough money in the account? This table maps out every single one of those scenarios. In test 1, everything's true, and boom, the transfer works. But look at test 2. The OTP fails, and the action is to block the transaction. This table is like a cheat sheet to make sure no combination ever gets missed. Next up, we have state transition testing. This sounds technical, but it's really just for testing anything that moves through a process or a workflow, where one thing leads to another. A perfect, everyday example of this is a login screen, which changes its state based on what you do.
So let's play this out. You get 3 tries to log in, right? On your first attempt, you enter an invalid password. Okay, no big deal. The system moves into its first state.
You try again. Still wrong. The system now triggers a transition to the next state. And on that third and final attempt, bam, account locked. The system makes its last transition. This technique is all about making sure every single one of those steps in that pathway works exactly as it's supposed to. So far, all these techniques have been pretty structured, very rule-based. But this last one, it's a little different. It relies on the most powerful testing tool there is, the human brain. This is called error guessing. And yep, it is exactly what it sounds like. There are no strict rules here. Instead, an experienced tester uses their intuition, their gut feeling, and their knowledge of common mistakes to guess where developers might have messed up. You know, they're thinking, I wonder what happens if I just hit submit on a blank form. Or what if I try to type my name into the phone number field? Or let's try to pay with a credit card that expired last year. An experienced tester's intuition leads them to try these things because they've seen exactly where systems tend to break over and over again. And that really brings us right back to the central theme of this whole thing. All of these techniques, from partitioning inputs to just guessing where the errors are, they're all designed to solve that impossible problem we started with. They let testers find the maximum amount of bugs with the minimum amount of effort. It's not about testing more, it's about testing smarter. So the next time you use your favorite app, think about it. What are its boundaries? What complex decisions is it making behind the scenes? And what simple mistake might an experienced tester just guess to try? You might be surprised at what hidden flaws are just waiting to be found. Thanks for watching.